All right, so this is September 26th, 11:58 a.m. In 2 minutes officially, we're going to start a kinematics workshop. And as of right now, we have no participants yet, but we started the record about 2 minutes before. Well, it's 11:59 now, but we're gonna start exactly at 12. So, regardless if the participants will show up or not, I will have a practice run, talk to myself for a few minutes, ask questions and answer, and then go from there. It depends who will come on. So it's 11:59. I'm gonna wait another minute and start exactly at 12, and then go from there. If somebody shows up, I will go back and start from the beginning and welcome them and work that way. So it's 12 o'clock. Hello, hello, and welcome. This is the Kinematics workshop. What is kinematics? Kinematics describes the motion. Motion of what? Motion of points, bodies, systems. In this particular workshop, which is designed for the beginners in physics, very, very beginner, basic. But if you're going to build a very strong base, then there is not even a sky is the limit in physics going to be for you if you have the conceptual understanding of this super, super basic material. So in this particular workshop, we're going to focus on distance, velocity, time, and acceleration, equations, and their application. This workshop is prepared and designed by one of the FSCJ science tutors. I'm a science and math tutor, and my name is Oksana Spears. My email is oksana.spears@fscj.edu in case you will have any questions after the presentation. All right, so then we're going to do this next is distance. So what is distance? Distance is very relative understanding, but it is a measurement from one point to another point. And by the dictionary, the definition is the amount of space between two things or people. It could be anything. The distance between stars and Earth, the distance between me and you, the distance between this table that I'm sitting in and my living room. The distance is between my house and the college. Distance can be the space, the vacant space. So what is the distance can be measured in? The distance can be measured in steps, feet, inches, miles, meters, centimeters, kilometers, you name it. As long as you know that it is a linear measurement. It cannot be squared, it cannot be weight, it's just a distance. It's a linear measurement. The most common ones that we need to know. Oh, how nice. Who is this? What is your name? Welcome. I know you have a microphone on, but you can type it in the chat room. Welcome to the workshop. So let me go back another slide. Welcome, and it's Ashton Snyder. Are you a student, Ashley? Okay, I see you typing it. Fantastic. I should say, are you some new students? Yes, ma'am. Oh, fantastic. So this is the perfect workshop for you because this is a very beginning workshop for the physics students. Ashton, what are you studying? What do you want to be when you grow up? And this is a super, super interesting topic that we have called kinematics, which means motion. And motion is energy. Energy is life. So, all right, let's see what you answered out here. I'm a new student. And this is actually recorded. So whatever I talk, you can rewatch it later in the same conference website. This is still typing. But I'm very happy to see that you've had a chance to make to this workshop. So I'm a computer-related crime investigation programs. How interesting. This is fantastic. All right. Have you been exposed to physics before? Like, have you taken physics prior? Oh, let's see. No, then it's excellent, because this is designed specifically for you. It's designed from fresh out of the, like, have no knowledge on physics whatsoever. All right, so we got kinematics. It seems maybe a new word to some people, but it's very simple. It just describes the motion of point, bodies, and system, and we all move in. And in this particular workshop, we're going to be focusing on distance, velocity, time, and acceleration, equations, and their applications. Ashton, will you be taking some physics, college physics, when you need it? I have only taken English in college prep. I am currently taking math. Okay. And astronomy. Astronomy is physics, all the space and stuff. This has everything to do with physics. The gravity and everything. Oh, excellent. So let's start here. So we're going to go, not time, because we're going to go back to distance. So distance in your astronomy could be from Earth to a moon. It's a measurement from one point to another, the amount of space between two things or people. So the distance is as simple as can be, but it's extremely important because there's a space between you and me. For example, I don't know how far we are, how far our house is. So it can be measured in steps, feet, inches, miles, meters, centimeters, kilometers, whichever. It's a distance. It could be, I don't know, anything. As long as you know that this is a linear measurement of space. The most common ones that we typically use in every day is a kilometer. It's a metric system, which is 1,000 meters. And then we have 1 meter, and it's 100 centimeters. And the most common one is it's a mile. Like we have 2 miles, 5 miles. So 1 mile is 1609 meters, or 1.609 kilometers. Or if you want to convert it to feet, it's 50 to 80 feet. So those are the most common ones you'll see. And the metric ones, you see just as much, especially in physics and astronomy. You're going to have kilometers. All right, so the distance, we got clear on distance, right? It's a linear space distance. Whatever this could be. It could be steps, inches, could be, you name it, but it has to be a linear. So it cannot be like meter square. It has to be just the meter itself. Or L, length. L itself, nothing else. Okay, we're good on distance, right? Ashton, we're good on distance? Let's see. Yes. So next one we move on is going to be time. So we cannot get out of time. So it never stops and it's universal. Time is always going. So time measured in seconds, minutes, hours, days, weeks, months, years, and such. So time is always going. Either we invest our time or waste our time. Hopefully this time is going to be very invested to you and you will find some value to it. So you don't feel like, oh man, I wasted my time. Because time doesn't stop. If we stop, time is not waiting enough. It keeps going. And as we know, 1 hour has 60 minutes. 60 minutes has 3,600 seconds, or 1/24th of a day. 1 day has 24 hours. 1 week is 168 hours, 365 days in 1 year, 52 weeks in 1 year. 10 years is a decade, 100 years is a century. So time is something that everybody deals with time. Like, oh, I got no time for that. But we all get 24 hours per day. Everybody does, believe it or not. What do we do with that? It's totally up to us. So we know units for time. Hours, minutes, seconds, and such and such. All right, the next one we're going to have is the distance over time gives us velocity. It's how fast. So distance, right? Distance, it could be meters, whatever, steps, and time, it could be seconds. So you can say, hey, I make 2 steps in 1 second. So this is your velocity, 2 steps, 1 second. So how fast is something moving? When you're driving a car, you have your speed limit, that's your velocity.
You are currently the only person in this conference.
Distance is per minute. Oh, okay. Currently 1 person. Well, meters per second, time per hour, kilometers per hour, steps per minute. Offline. Person gotta leave me. All right. Well, okay. Steps per second, distance per time. Meters per second, miles per hour, kilometers per hour, steps per minute. Average velocity. How do we find average velocity? We add all the velocity and divide it by number of velocities. So we have initial velocity or original plus velocity could be final, and we divide by 2, we get our average velocity. Yeah. The next slide is velocity over time gives us acceleration. Measures in distance per time square. Why? Because velocity over time, and velocity is what? Distance, so we'll do meters per second, and our time is second again, and it's going to give us meters per second square. That's going to give us acceleration. If we're speeding up, positive acceleration. If we're going up, our velocity goes up. Slowing down, negative acceleration or deceleration. Acceleration times gives us velocity. So we'll take acceleration, which is meters per second square, multiply by time, which is second, give us meters per second, which gives us velocity. So all the kinematics equations are built off of time and distance. Everything else is built off of it. So if you know your measurements on time and distance, you can find your velocity or acceleration. All right, we'll do next slide. We're going to work on some examples. And examples are speed limit is 35 miles per hour. How many kilometers per hour? Meters per second, feet per second. Harvest, and then we have 1, 2, 3, 4 examples. All right, so we got 35 miles. Let's see what's the next one. The next one would be say, how do we solve it and where do we start? So the way my strategy on starting and solving the physics is to write down what I have. I have 35 miles an hour. So 35 miles for 1 hour. All right, so what do we want? We want how many kilometers per hour? So I'm looking for what? I'm looking for kilometers per hour. So hour is changing. We don't want to change anything. But we need to do something with miles and kilometers. Because we got to end it up with kilometers. Earlier in the slide, we said how many. We have 1 mile is 1.69 kilometers. So let's go back here. And we got 1 mile equals 1.69 kilometers. What do we do from here? We want kilometers, right, per hour, and we have miles. So we are going to, let's get the clean page next page. So we have 1 mile equals 1.69 kilometers. Speed limit is 35 miles per hour. It's going to give us 35 miles. We want kilometers, so we're going to put my kilometer on top, 1.609 kilometers, and divide by 1 mile. So my miles cancel out. I multiply these two numbers, and that's how I get my kilometers per hour. And when I multiply them, I got nobody to verify me, but let's see what we get. 609, get 56, and I'm going to round to the whole number, nearest whole number. So we're going to have 56 kilometers per hour equals 35 kilometers, 35 miles per hour. All right, this one's done. Fantastic. Attention. So which next one we have? The next one we have, what about meters per second? 35 miles per hour will be meters per second. Where would we start? We want meter per second. So go back here. 35 hours. We have, if we have 1 mile, kilometers, it's gonna be 1609 meters. And we're looking meter per second. So we're gonna have 1609 meter in a mile. Fantastic. So mile is going to go away. We're going to meter per hour. It's been 1 second. So if you'll do 35 and 1609, I'm going to have 56,315 meters per hour. Okay, but I am looking for meters per second. We know that 1 hour equals 3,600 seconds. So we want what? We want per second. So second has to go at the bottom. So we want meters. And we want seconds. But it's also said that it's 3,600 seconds. So we're going to make sure to put our 3,600 at the bottom as well. And in here we said 1 hour, 36 seconds. So we're going to get our hours goes away. And indeed, we're going to have our meters per second. Now we got to work with our numbers. So 56,315 divided by 3,600. We're going to divide, not multiply. So 56,315 divided by 3,600. I'm getting 15.6. I want to do, because it's a meter, it's a smaller distance, smaller measurement. I want to have a twist one then from on this case. So meters per second. That is my answer from this guy. All right, so what's the next question? We got meters per second. Next one, we want to do feet per second. All right, so since we already have meters per second, it's 15.6. Yeah. Put all the animation, let's clear them off. And let's just include the other side. No, oh, fantastic. Love that. So we had what? We had 15.6 meters per second. So how do you do to get, you want to get the feet per second. You're looking for feet per second. That's what we're looking for. Because we already have a second, so we leave our time alone. We need to just convert that distance. So let's see, what's the closest one that we can find from meters to feet? What are they? Let's see what we can have. So what do we got here? We have 1 mile. So if 1 mile is 60 to 80 feet, and it's 1609 meters. So 1609 meters equals 50 to 80 feet. We can go from there, or we can look it up something else. 50, 50 to 80 feet. Looks like it's a lot difficult. So, 50 to 80 feet. It's also 1609 meters. Oh, if we're going to divide 50 to 80 by 1609, 1609, we get 3.28. From here, we get 3.28 feet, not feet, yeah, feet in 1 meter. Not per meter, but in 1 meter. So we can probably put an equal sign here. 1 meter. Okay, so we know that 3 points, or actually from the given information, that's what we find out. Feet equals 1 meter. So what do we do? I would put 3.28 feet, because we're looking for feet per second, over 1 meter here, equals, what we're going to do, we have 15.6, not actually equals, we're going to multiply that, meters per second. Because our intentions are to get rid of meters, but to have a feet per second. All right, so if the speed of 35, it was 15.6 meters per second. Let's see how many feet per second it's going to be. So we take our 3.28 multiplied by 15.6. We get 51 feet per second. So here, 51 feet per second. So now our first question, we had on our example, 35 miles per hour is, what was it, 51. It's the same thing, it's 51 feet per second. Excuse me, and then we had how many meters? We had 15.6 meters per second. And then we did our miles as well. And kilometers, we did kilometers. All right, so this is first example. Took a minute, but this is mostly conversions, and it's very important to know now how to convert from one measurement to another measurement. And make sure that you do not make any other units, like biggest mistake would be you don't want to do second square, like you don't multiply them, you divide them, you make sure that they cancel them out. Or feet square in it. You make sure you line up the units. Linear with linear, time is time, distance with distance, time is time. All right, so let's work another, for example. So next one is, car is going 10 miles per hour, then increase to 30 miles per hour. What is the average velocity? Okay, well, average velocity is you add one velocity to your velocity, another one, and divide them by 2. That's going to be your average velocity. Do like velocity O, or increased I. However you want to know, you see I or nothing in it, numbers, 1, 2, could be a different notation. So in our case, we have 10 plus 30. Divide by 2, you get 20 meters per second. Actually, it's miles per hour. So you get 20 miles per hour. So in this case, your units are the same. They are lined up. Units, you always want to verify your units. Okay? Move on to the next one. The next one is going to be from rest to 60 kilometers per hour in 20 seconds. What is the acceleration? This is going to be for a minute. We got to think here. I'm going to close this off. So we have, the question is, from rest to 60 kilometers an hour in 20 seconds. So rest is velocity originally was at rest, 0. Then our final velocity that they told us, 60 kilometers an hour. And the time we have is what? 20 seconds. And you're looking for acceleration. How do you find it? You have time of 20 seconds. You have velocity of 60 kilometers per hour. How would you do A? Acceleration. What did you say over? Acceleration is what? Velocity over time gives us acceleration. So acceleration equals velocity over time. Oh, look at that. What's our velocity? You take your average velocity, in this case is 0.6 divided by 2. You gotta add both of them. So do we need to do the 1/2? Because we gotta do two velocities. So we are doing that. So we have 1 velocity, 2 velocity. And a time. Velocity equals AT, right? So in this case, velocity equals AT. Okay. Our velocity is in kilometers per hour. Our time is in seconds. So we gotta be consistent. We need to either change it to everybody to seconds or seconds to hours. What's our way of doing it? What's the best way of doing it? What's easier? So we're gonna end it up with this. We have acceleration. We know this velocity over time gives us acceleration, and we look at acceleration. But we have velocity in an hour, 60 kilometers per hour. 60 kilometers per hour. But our time is in seconds. How are we going to convert it? So let's see. If we wanted to per second, then however many kilometers per second, we're going to do what? We're going to multiply kilometers per second. It's gonna be a tiny, tiny number. If you want to have a small number, then we use seconds. If you want to do a bigger number, then we change our seconds to hours. But it doesn't matter much. Either or, you're gonna come up with the same answer. So let's do this thing. Let's say 1 hour is gonna give us 3,600 seconds. 300. So we're going to cancel out hours, and we have kilometers per second. Because you do always want to have your units consistent. That's the biggest, big thing. Consistency of your units. So I will do 60. If you take 60 divided by 3,600, then we have this number. We have 0.01. It's 6666666. That's because it's going to be much better in a fraction. We can do fraction, or we can just do 6, 7. If you're going to do in fraction, 6 divided by 6 is just going to give you 1, 6. Right? 1, 6. Not 1, 6. You can do 160 kilometers per second. 160. So if you want to do exact, you want to keep it as fraction. If you want to close enough, you do decimals, just like this. Plus, we got our seconds. Now we're going to have, this is our velocity. Now we're going to be divided by time. So I'm going to keep a fraction. I have fraction. So we're going to have 1 over 60 kilometers. I'm going to put a little bit off. I want to close the whole thing. So I know that 1 kilometer, 60 seconds. And it's just our time, right? This is our velocity after we convert it to the same units in seconds. What was given to us, velocity was given to us in 60 kilometers per hour. When we converted, because we took our 60 and divided by 3,600, we got 160. 20 seconds. And we discussed earlier that our acceleration is nothing more than just the velocity over time. Okay, so what do we do from here? How do we get acceleration? Acceleration from here, we're going to take our velocity, which is 160. We're going to put seconds at the bottom, kilometer at the top. And then when we divide something, the fraction, so we change our to multiply, and instead of that, we're going to do it at the bottom. Right? So we're going to have 20 seconds. Because we are dividing it by time. So in definition of division, you keep your first one, which is right here. You change your to multiplication and you split. And we do want for our acceleration distance per time square. So what you do, you have 1 kilometer over 2 times 6 is 12, 0 seconds. You know what? This is the square. What about if we do meters? So it's going to be a little bit nicer number. So if we're going to have, you know, that 1 kilometer equals to 1,000 meters. So if we have 1,000 meters, 1 kilometer is 1,000 meters. 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 1 kilometer is 1,000 over 1200 seconds square. We can comfortably close those zeros. We have 1012, which is 56 meters per second squared. This is your going to be final, the most nicer looking acceleration that you did if you took it 20 seconds from zero, from rest to 60 miles an hour. Not miles, kilometers. Let's see what we have, kilometers an hour. Yeah, kilometers. 60 kilometers an hour in 20 seconds. What is the acceleration? Your acceleration is 56 meters per second squared. If you have some other way you'd like to solve it, let's do it. If you want to leave it as 1 kilometer per second squared, let's see what's that going to look like. We're going to take 1 divided by 1200. And you have a lot of decimals, and this is just much nicer looking. But if you want to leave it in kilometers, you have 0.000833. And again, because it's a decimal, it's not as exact. This example, it's better just to leave it as fraction, because in this case, fractions are a lot more exact and specific. And here you have, you can leave it like maybe, so this is 0.00081230 kilometer per second square. If you want to do the rest of significant numbers, so you do 1 or 8.33 times 10 to the negative what? 1, 2, 3, 4. That's 1, 2, 3, 4. The negative 4 kilometer second square. All this is the gives you the exactly same answer, just the different forms and different notations. So it depends on your professor and depends what they want from you. All this is correct. You just different looks. Very different looks. You will like, whoa. But all this is the same. Just 5, 6 is the most exact one. This one's closer. So this is our acceleration. If we get like, hey, I know what my acceleration will be if I take me 20 seconds to get from 0 kilometers per hour to 60 kilometers per hour. My acceleration is, if you like in meters, it's 56 meters second square. And if you like in kilometers, it's whichever you want significant numbers you want or significant form. The same thing would be for the deceleration, like if you were driving 60 miles an hour, 60 miles or 60 kilometers, how you get 60 kilometers, 60 kilometers an hour, and it took you 20 seconds, the same thing, but it would be negative because you're decelerating, so you're slowing down. So if you were driving, we'll put all this off. If you were driving 60 kilometers an hour, and it took you 20 minutes to make a stop, complete stop, 20 seconds, not minutes, minutes is too long. You're driving 60 kilometers an hour, which is we can comfortably find out what is it going to be in miles or feet. It's a simple conversion. But in this case, we'll use kilometers an hour, 20 seconds. And you stop, so you know it's 56 meters per second square. But it's negative because you're slowing down. If you specify that you are decelerating, and in some cases they don't want to have double negative, then you give them 5, 6 deceleration. But if you say accelerating, so it's negative 5, 6. So it depends on notations, but make sure you specifically know the meaning of it, because this is a decelerating, slowing down. This is a speeding up. All right, but it's the same principle, same stuff. All right, so I'm going to close this one. We'll move on to the next one. Oh, we got 60 miles per hour to stopping point in 30 seconds. What is the distance? Oh, this is even better, because we're looking for the distance. We're not looking for acceleration or deceleration. We want to know how many miles, feet, meters, whatever the distance is. Distance measured in linear, so it's the feet, meters. In this case, probably going to say this mile. Naya, Nia, Pete. Hello. Well, welcome. I mean, you come in a little bit late, but let me know who you are. Hi. I'm so glad you're in. We do still have 15 minutes, so I'm not sure what your level of physics is. Please tell me something about yourself. I'd like to, know where we are. Because what I've been doing in here, I've been going over the slides, and then we've been doing some solutions. Like we've been solving these examples. And the slides were, I would say, elementary, but not really, because they're extremely important. Like we had distance, it has to be linear. It's below, I believe my message. I wanted to come check it out. I'm in nursing program, and I was typing another dosage code. Student will count. Actually, I did have a dosage calculation workshop. It was 2 weeks ago. I do have PowerPoints and slides for that, but that workshop has not been recorded. This one is recording it, but the dosage calculation shop was not recorded, and I did conduct it 2 weeks ago. But let me know where you are in the physics, because this is kinematics. Let me tell you quickly what the kinematics is. Kinematics is the motion of points, bodies and systems, so it's like moving. And we are focusing on distance, velocity, time, and acceleration. And it is definitely for the very beginning in physics. So nursing program, you do use a little bit, I guess more like a conversion. You can use a lot of it. If you go over in here for the conversion, like you use your hours, minutes, and seconds for sure, days, weeks, decades will come out. Yes, dimensional analysis. Yeah, so you definitely can take, some benefit out of this workshop, even though we only have a few minutes left. So if you want to, we can go look over them quickly, and then if you have any questions, I'll be more than happy to answer them for you. Or if you can look at some examples and you want to work them out with me, I'll be more than happy as well. But the slides themselves are very, we can go very quickly. Okay, thank you so much. So the first one is, and here we do time. And in nursing, you do use your time, typically 1 hour, 60 minutes, 30 seconds, 24 hours. So it's universal, and we do measure that. The next one is, okay, so we did a distance. Distance is the measurement from one point to another point, the amount of space between two things or people. So that's the distance. The most common ones is 1 kilometer, 1,000 meters. 1 meter is 100 centimeters. Then we do miles in here. Mile is 1609 meters, 1.609 kilometers, 50 to 80 feet. So, and it has to be linear one. Then when we do distance over time, gives us velocity. It's how fast something's moving. So in your nursing thing, you're probably going to do very much so. You'll be like 20 drops per second. That's your dosage calculations right there. That's your velocity. It's how you're fast. Like your measurement per time. So That's definitely in your nursing program. Or you're gonna do like when you do your IV dripping, you count for how long it will take you. For example, they say how many mLs it will dispense an hour or per minute. So it's again, in your case, instead of distance, you use this dosage per time. And it's very important when you do those conversions that they have to cancel each other out. Like in here we did velocity, which is in your case would be IV drips, your dosage, and like how many dosage per day. So very similar. But you do want to make sure this is acceleration. We don't get there yet. So you do want to make sure that your units are canceled out in your dosage calculation. And then in our physics in here, we talked about velocity over time gives us this acceleration. It's how it speeds up. In the nursing program, you will be like a heartbeat speeds up, or you have so many beats per minute. Or when you do your pulse rate, you do what, like 60 a minute or 120, it's extremely high. Or like even anything above 100 is high. So you're going to do the velocity is your heartbeats, IVs, and you use physics and nursing just a lot. All right, so this is acceleration. And then here's I had some examples that we were working out. And the last one I have is from 60 miles per hour stopping point 37. What is the distance? So we were looking for the distance in here. But Nia, if you have specific question, like I have a clean in here, so we can go ahead and clear this off. And if you have a specific example for your dosage calculation or for your practice, please let me know. I'll be more than happy to work it out with you because these workshops are very flexible. It depends on the participant. So if you want to work something out, I'm here. Just do this. What is the next virtual tutoring you will have? Virtual tutor. What do you mean by virtual tutoring? You go to Brain Fuse and you schedule appointments with me. I'm open. I work Saturday, Sunday, Monday, and Wednesday. I work 4 days a week. You go tutor match, and you schedule a meeting with me, and we do the virtual tutoring. And I am one of those dosage calculations as well. So if you need assistance how to schedule appointments with me, let me know. But there's at the top is my email address. You can always email me as well. Here's my email right here. Oksana.Spears. What is it? But typically, okay, thank you so much. I will definitely be using that. When you go to your Brain Fuse and the student main page of your FSCJ, you go Brain Fuse. In the middle, you will have a tutor match. So you click on the tutor match, you pick your subject. In your case, could be whatever the subject you have. Dosage calculation could be one of them. And you pick my name and you schedule an appointment. I think I even have something open today. So look. I have 32, 230. No, looks like today the only one I have is 3:30. 3:30 to 4. Everything else is booked. So maybe something for tomorrow you can find. Okay, thank you. But do you want to have anything like, do you have any questions about physics? Or if you have a question in here, because this is, the dosage calculations, they are directly related to velocity and to physics. Like physics, you can relate physics to any topic. Physics, anything. Like we're talking right now, we're burning energy, we're using gravity, we're using time. This is all physics. Any topic can be directly related to physics. So you can flip it, strip it, however. So if you have a question that you like to work on, go ahead and type it in. I still have 5 minutes if you're here. This is a recording. And I would like to invest my time, not waste students' time, but invest their time to have it beneficial. Let's see. It says you're typing something. Oh, working on defining a distance. This was a good one then. Okay. As soon as I take my exam on Monday, I will be looking for you on brain fuse. Well, maybe you should be make sure you're very well prepared before your exam. That's not gonna hurt also. Because it depends what program you are. You said your nursing program. They are very, very tough on dosage calculations. There is like no joke. And I guess the biggest thing I can recommend for you, what is it? What's given and what's looking for. So you see what's given to you. Given, like I don't know, grams per whatever per day. Given, and then what's needed, what's prescribed. What do you need? And then you'll be like looking for, I don't know, ml per dose. So when you set up your equations, make sure your all units cancel out. For example, given grams per day, the doctor, it's available, I don't know, 2 grams per day, okay? In 2 grams. And you have to break it in QAD, which is going to be like 4 times a day. 4 times a day, right? QAD, so 4 times a day. And they're gonna go say, for example, 0.5 grams in 5 ml. So you want to know how many mLs per dose. So given 2 grams per day, they want to know how many mLs per dose. And this is whatever the medicine X. So you know that you need QAD. So 2 grams a day divided by 4, you're going to have 0.5 grams per dose, because you want to do the dose first. And in the ml, you can do grams per ml. So you're going to have 5 ml per dose. But make sure your grams like cancels out and you have your ml because that's what you want. And just make sure when you set up your example, your equation, make sure your units cross out and cancel out. That's the biggest tip I would say. And a dosage calculation. For example, you make sure like if you're looking for ml per hour, okay, this is what you're looking for, right? mL per hour. And they give you something per second or whatever. So even if it's per second, make sure you have it has to cancel stuff out. So you list out at the end, it's ml per hour. Then, for example, if they do seconds, but we need hours, so you'll do hour in here for 3,600 seconds. As you know, 1 hour is 3,600 seconds. Put 1 hour at the bottom. And then you get they say every 20 seconds. And in this case, our time total is going to cancel out. And you're just going to get your mLs left. So whatever the ml. So that's all I can say. Unless you have a specific example, like from your practice test. That way you don't have to see me after the test. It's much better when you see me before the test, not after. After it's good too. It's still, any time is better than no time, but it's better sooner than later. It's better before the exam than after the exam. All right. Oh, I see, because I was so scared of dimensional analysis, but now I see that it is the best way to get the answer. That is the, yeah, totally. Like for me, it is. So if you have examples, specific ones, I don't know, like what they get, 5 ml for 2 grams, and a child needs, I don't know, 10 grams per day, or per dose, per, let's say dose. They want to know how many mLs you're going to give that child. So how are you going to set up? You're going to set up, you're looking for mLs. How many mLs? You're going to give the medication to the person, to the child. If they need 10 grams per dose, and it's 5 mLs per 2 grams. So you say, I'm looking for mLs. I'm going to put my mLs at the top. 5 mL per 2 grams. Okay, so what is my 10 grams per dose? I'm going to look for mLs and my dose. I don't need my grams. The grams got to go. So what I have, 5 times 10, 50. 50 divided by 2 is 25. So you're going to give a child 25 ml per dose. There you go. Yeah, you're right. You're absolutely correct. So when you set this up like this, then it should be clearly cancel out, and you only isolate what you need. Another strategy is you focus and you take only what you need. You don't use more or less information. Because a lot of stuff, they got to give you a lot of bluff, and the challenge is to isolate and only take what you need. Because they can say, I don't know, the child has blue eyes. You don't really, I mean, it's nice to know what color eyes they have or what shoe size, but this is not, it's irrelevant to what we need to find it. All right, well, time is up. I got to go, but it was very nice meeting you, and thank you so much for stopping by. Hopefully you learned something. You didn't waste your time. You invested. I see you still typing something. Also, I'll read your type. And then if you need to, schedule is before or after. Thank you so much. You're welcome. It was nice meeting you, and best of luck in your nursing program. Bye-bye.
You are You are currently the only person in this conference.